Hi, everybody. It's David again. In virtual speech again, looking at the intersection between AI and XR. And virtual speech have added a Chat GPT bot, which is amazing. It's really good. It reacts really well. And I was yesterday at an event, an online event about the enterprise or the industrial metaverse. And I wasn't very impressed by the level of expertise and knowledge from the speakers at that event. It was an economist event. None of the questions got answered that anybody asked, not just me. There were a couple of good speakers in there, so Alan Smithson, amongst others. But generally, the level was pretty low, and they didn't even explain what the industrial metaverse is or the metaverse is and how it differs from, for example, digital twins, which were kind of used interchangeably. So I thought just to do something different, I'm going to come into VR and I'm going to speak to Chat GPT and see what Chat GPT knows about the industrial metaverse. So here we go. So this is virtual speech. This is an app which you can download on the Oculus Quest. It's an amazing application to help you with your public speaking, but it has this really cool functionality where you've got Chat GPT in this kind of meeting room environment where you can just have a chat about anything. So there's a disclaimer there, and then basically at the moment, this is what you can do here is just, I believe Chat GPT is behind the scenes, so you can talk about anything, as you'll see in a moment.
Hi, David. My name is Cynthia. What would you like to talk about today?
Hi, Cynthia. I'd like to talk about the industrial metaverse. Generally, I would like to find out more information about that. Do you know anything about that?
Hi, David. Yes, I do know a bit about the industrial metaverse. It refers to the integration of physical and virtual worlds to optimize industrial processes and operations. It utilizes technologies like artificial intelligence, augmented reality, and Internet of Things to enhance efficiency, productivity, and collaboration in industries. Is there anything specific you would like to know?
Yeah, I'd specifically like to know how the metaverse part of industrial metaverse adds value to businesses.
The metaverse aspect of the industrial metaverse adds value to businesses by enabling real time data collection and analysis, immersive simulations and training, virtual collaboration and remote assistance, and predictive maintenance. It allows businesses to optimize processes, reduce downtime, improve decision making, and enhance overall operational efficiency. By creating a virtual layer that integrates with the physical world, the metaverse enhances productivity and drives innovation.
That sounds like marketing bullshit, to be honest. Could you tell me specifically how the metaverse part allows you to improve data collection?
Certainly, the metaverse part of the industrial metaverse enables improved data collection through various means. For example, by integrating sensors and IoT devices in the physical environment, real time data can be collected and fed into the virtual environment. This allows businesses to monitor and analyze data more effectively, identify patterns, detect anomalies, and make data driven decisions. Additionally, virtual simulations within the metaverse can generate large amounts of data for analysis and optimization of industrial processes.
It sounds like these are things which could be done on a normal two-dimensional screen instead of the metaverse. How does the metaverse help specifically as compared to using that on a normal 2D screen?
While certain aspects of data collection and analysis can be done on a two-dimensional screen, the metaverse provides a more immersive and interactive experience. By leveraging augmented reality or virtual reality, the metaverse allows users to visualize and interact with data in a spatial context, making it easier to understand complex information and identify insights. It also enables collaborative workspaces where multiple users can interact with virtual objects simultaneously, fostering enhanced communication and decision-making. Overall, the metaverse enhances the user experience and brings a new level of engagement to data collection and analysis.
Okay, thanks. It sounds like their metaverse is specifically adding value in terms of collaboration, because today you could have an augmented reality application that displays real-time data, but that I wouldn't call that a metaverse application. Whereas a metaverse application is probably something where you've got data from different backgrounds or different databases, and you have, of course, the multiplayer element of it. Is that right?
Yes, you're correct. The metaverse application adds value in terms of collaboration by allowing users to access and interact with data from different backgrounds or databases. It also incorporates the multiplayer element, enabling multiple users to join and collaborate in the virtual environment simultaneously. This collaborative aspect, combined with the integration of diverse data sources, distinguishes the metaverse application from a simple augmented reality application displaying real-time data.
So it seems like there's a couple of different kinds of ways to access the metaverse. You could access the metaverse via a web application, and you can access the metaverse via a dedicated installed application on your device. Could you highlight some of the key pros and cons between those two different approaches for me?
Pros: easy accessibility as it can be accessed through a web browser without requiring additional installations. It provides cross-platform compatibility, allowing users to access the metaverse from different devices. Updates and maintenance are typically managed by the service provider. Cons: limited native functionality compared to a dedicated installed application. Performance may be impacted by internet connectivity and browser limitations. It may have fewer customization options compared to a dedicated application. Dedicated installed application pros generally offers richer features and functionality due to its dedicated design. Can provide better performance and user experience as it is optimized for specific devices. Offers more customization options and may have offline capabilities. Cons: requires installation on the device, which may require additional storage space and regular updates. May have limited compatibility across different operating systems and devices. Maintenance and updates are typically managed by the user. These are general considerations, and the specific pros and cons may vary depending on the particular metaverse platform and application in question.
Wow, that's a good answer. So, web-based applications, when you want to have improved accessibility, perhaps not needing to worry about software updates, perhaps taking advantage of the latest technology in terms of what other providers might be doing behind the scenes, and then an installed client if you want perhaps more configurability, slightly better performance, and more control of the application. Is that a good summary?
Yes, that is a good summary. Web-based applications offer improved accessibility and convenience, as they do not require software installations and can leverage the latest technology advancements. They are generally easier to maintain as updates are managed by the service provider. On the other hand, installed client applications provide more configurability, better performance, and more control over the application. They may be preferred when customization and specific device optimization are important considerations.
Somebody once told me that with a web application, you can't view very large and complex 3D models. Is that the case?
Viewing large and complex 3D models in a web application can be challenging due to limitations in processing power and bandwidth. While advancements in web technologies like WebGL have made it possible to render 3D models in browsers, there may still be performance issues when dealing with very large or complex models. However, with optimization techniques such as level of detail, LOD, rendering and streaming technologies, it is possible to overcome these limitations to some extent. It ultimately depends on the specific capabilities and optimizations implemented in the web application.
Thank you. Can you recommend any solutions in order to optimize 3D models for metaverse applications? So specifically converting models from a CAD system into models which are suitable for a metaverse application.
Simplify the model geometry by reducing the number of polygons while retaining essential details. 2. Use level of detail, LOD, implement different levels of detail for the model to display lower polygon versions when viewed from a distance, improving performance. 3. Optimize textures, compress textures and reduce their size to improve loading times and overall performance. 4. Implement occlusion culling, hide or remove unnecessary or obstructed portions of the model from rendering, improving performance. 5. Use streaming technology, load parts of the model dynamically based on the user's viewpoint, minimizing initial loading times and optimizing performance. These solutions help balance visual quality and performance for efficient usage of 3D models in metaverse applications.
What about the importance of draw calls on immersive applications, specifically virtual or stereoscopic augmented reality applications?
Draw calls refer to the number of times the graphics hardware is instructed to draw an object or a set of objects. In immersive applications like virtual or stereoscopic augmented reality, minimizing draw calls is crucial for optimal performance. High draw call counts can lead to decreased frame rates and increased latency, resulting in a less smooth and immersive experience. It is important to optimize the rendering pipeline, reduce unnecessary draw calls, and use techniques like batching and instancing to efficiently render objects in order to maintain a responsive and immersive VR or AR experience.
That's a great answer. Thank you very much. So we've talked about the importance of whether it's an installed client or a web application. We've talked a little bit about 3D optimization. What are the most important things when it comes to the data backend of the industrial metaverse applications?
Ensuring seamless integration of data from various sources, such as sensors, IoT devices, databases, and external APIs, to provide a comprehensive view of the industrial processes. 2. Data security, implementing robust security measures to protect sensitive industrial data from unauthorized access, breaches, or tampering. 3. Scalability, designing the backend to handle large volumes of data and adapt to growing demands, allowing for future expansion and accommodating increased data processing needs. 4. Real-time processing, enabling real-time data processing and analysis to provide up-to-date insights and support timely decision-making in industrial operations. 5. Data analytics, incorporating analytics capabilities to derive meaningful insights, identify patterns, and optimize processes, enabling predictive maintenance, anomaly detection, and performance improvements. These factors play a vital role in ensuring the efficiency, reliability, and effectiveness of industrial metaverse applications.
Great. So there's two major components to the industrial metaverse. One is the data behind the scenes. Some people call that digital twin, as far as I understand, but you need to have accurate data, up-to-date data, or data which is understood and of known quality. And then there's the front end of the industrial metaverse, which is the experience that you have either through a 2D screen or through a virtual reality device or through an augmented reality device. What's the most important part of those two components of the industrial metaverse, in your opinion?
In my opinion, both components of the industrial metaverse are equally important, as they complement and rely on each other. Accurate and up-to-date data is crucial for meaningful insights, decision-making, and optimization of industrial processes. It forms the foundation for the front-end experience, ensuring that the virtual representation aligns with the real-world operations. On the other hand, the front-end experience, whether through 2D screens or immersive devices, enables users to interact with and derive value from the data, fostering collaboration, visualization, and efficient problem-solving. The combination of reliable data and a user-friendly front-end interface is essential for the success of industrial metaverse applications.
So, one thing that I've heard about is that a lot of people don't like to wear head mounted devices, both augmented reality or virtual reality. How can the industry improve accessibility to these devices? And do you have any advice for companies who are trying to introduce these devices, especially to older people who are particularly averse to wearing headsets?
Companies should focus on designing lightweight and comfortable headsets that minimize discomfort and fatigue during prolonged use. Improvements in materials, weight distribution, and adjustable straps can enhance user experience. 2. User-friendly interfaces. Simplifying user interfaces and streamlining interactions can make headsets more intuitive and easier to use, reducing the learning curve for older users. Implementing voice commands or gesture-based controls can also enhance accessibility. 3. Training and support. Providing comprehensive training and support for users, particularly older individuals who may be less familiar with the technology, can help them feel more comfortable and confident in using headsets. Offering clear instructions, tutorials, and accessible customer support can make a difference. 4. Alternative display options. Exploring alternative display options, such as handheld devices or large screen displays, can provide an alternative to headsets for those who are averse to wearing them. These options can still offer an immersive experience while catering to individual preferences. By focusing on comfort, usability, training, and providing alternative display options, companies can improve accessibility and address concerns for individuals, including older users, who are hesitant to wear head-mounted devices in the industrial metaverse.
Thank you. So we've talked about the experience of users, we've talked about the data backend, and then the front end. One thing I'm very interested to know is that in industrial metaverse applications, we seem to have this choice of fully virtual environments, computer-generated environments like this one, or we have the ability to capture reality, so either through a laser scan or perhaps something like a neural radiance field. What do you see as the most important technology in this field going forward?
While both fully virtual environments and reality capture technologies have their significance, the most important technology going forward in the field of industrial metaverse applications is likely to be reality capture. Reality capture technologies, such as laser scanning, photogrammetry, and neural radiance fields, enable the creation of accurate and detailed representations of real-world assets and environments. This allows for more precise digital twins, enhanced visualization, and better alignment between the virtual and physical worlds. Reality capture technologies provide a foundation for immersive and data-rich experiences, making them a crucial aspect of the industrial metaverse.
Thank you very much. Now, one final question in the style of Kent Bai. What do you think is the ultimate potential of industrial metaverse?
The ultimate potential of the industrial metaverse lies in transforming the way industries operate by seamlessly integrating the physical and virtual worlds. It has the potential to revolutionize processes, optimize efficiency, enable remote collaboration, enhance decision-making, and drive innovation across various industries. The industrial metaverse can unlock new levels of productivity, sustainability, and safety, while also fostering economic growth and global connectivity. It has the power to reshape industries and create a future where advanced technologies work in harmony with human expertise to unlock unprecedented possibilities.
Thank you very much. It was very good to talk to you today, very informative. Have a great day. Bye-bye.
Thank you, David. I'm glad I could provide you with the information you were looking for. It was a pleasure speaking with you. Have a great day as well. Goodbye.
So I think you'll agree that virtual speech here is a really interesting application, and Chat GPT, as you can see, can give you a kind of simulated, pretty good conversation. Of course, my understanding of Chat GPT is that it bases its answers on what you expect to hear. So if I give a question that includes the words neural radiance field photogrammetry, we'll look up those things and try to figure out what people talk about in that context. So I'm not too sure. It doesn't feel like a real conversation. Of course, it feels like somebody who's reflecting the words that you say to them. And of course, in many conversations, that is the case. People just kind of reflect back to you and give their opinions. But I still think I probably got a better level of knowledge from Chat GPT than some of the presenters on the Economist event. So that's it from me. The app is virtual speech. It's an amazing thing. You can use it to practice your public speaking, and really cool, you can role play with Chat GPT. Now, there are other apps on the market that, like Replica AI, for example, that allow you to chat with bots, but none of them are using Chat GPT as far as I know. So really cool application. And that's all from me for now. Bye-bye.